Here is a short video of the reaction of superacid with paper. Our concept of acidity came from the ancient Greeks, who defined sour-tasting substances as oxane, which mutated into the Latin word for vinegar, acetum. This ultimately became acid. Acid substances were eventually found not only to taste sour, but also to change the color of litmus paper and corrode metals. Not only the concept of acids evolved over the time, the ultimate possible strength of the acids has also evolved. The simple acids of natural products, such as the fermentation products of vinegar, lactic acid in buttermilk, citric acid in fruit juices, give way to the more stronger mineral acids of alchemists. In 1927, James Brand Conant, a Harvard chemist, was developing an acid mixture from sulfuric acid and fluorosulfuric acid. He obtained a solution which was literally 1,000,000 times stronger than the earlier acids themselves. He coined the term superacid to denote the new mixture. In 1960s, George Olah developed an even more powerful magic acid. Here we will be discussing some aspects of superacid chemistry. In his paper in 1909, Sorensen developed a colorimetric assay for acidity. More importantly, he defined the concept of expressing acidity as the negative logarithm of hydrogen ion concentration, which he termed pH. Every time the pH drops by 1 unit, the hydrogen ions increases by 10 times, and the acidity of the solution also increases by 10 times and is more reactive. Lemon juice has a pH of around 2, which means that one hydrogen ion is furnished by the acid for every 100 acid molecule in the juice. And stomach acid is having a pH of 1, which means that one hydrogen ion is furnished for every 10 molecules of the acid. The pH scale really works only up to pH 0. For example, concentrated hydrochloric acid is having a pH scale of 0, where all the molecules of hydrochloric acid are ionized, and we get one hydrogen ion for every hydrochloric acid molecule in the solution. The situation of pH 0 represents the possible theoretical limit of ionization, that is, the complete ionization. No acid can be defined which is more ionizing than 100%. In order to define the acid character of superacids, which shows more acidic character than the 100% ionization, Ronald Gillespie introduced the concept of Hammett acidity function. The Hammett acidity function was introduced by Lewis Hammett. The acidity function depends not only on the ionization but also on the tendency of the proton to protonate a base based on the reaction as seen H plus B, a base, giving BH plus. For the particular reaction, we can define Hammett acidity function as H0 equals pK of the ion minus log concentration of base by the conjugate acid of the base. For sulfuric acid, the Hammett acidity function value is 11.93, which can be approximated as 12. Any acid which has an acidity function lower than 12 is termed superacid. Hammett acidity function values of some superacids are given in the table. For sulfuric acid, the Hammett acidity function value is minus 12. For perchloric acid, it is minus 13. It implies that perchloric acid is 10 times stronger than sulfuric acid. Trifluoric acid is having a acidity function value of minus 14.6. Fluorosulfonic acid is having minus 15.6. And magic acid, which is a mixture of fluorosulfonic acid and SBF5. Based on the composition, its acidity function value ranges between minus 21 to minus 24. All these acids are having acidity function values lower than sulfuric acid and are termed superacids